New York's LaGuardia Airport. After half an hour of waiting, the pilots of a USAir Fokker F-28 are finally cleared for takeoff. But as soon as their plane gets airborne, things start to go badly wrong. What you're about to watch is not just a story about the dangers of cold weather. It's a story about how a chain of seemingly minor events can lead to disaster. This is the story of USAir Flight 405. New York City, March 22nd, 1992. It was just after 8 o'clock in the evening at LaGuardia Airport when 47 passengers boarded a USAir Fokker F-28. They were bound for Cleveland, Ohio, a 1.5-hour journey. Many of the passengers were returning home from business trips to New York, while there were also some people visiting family in Ohio. Looking after them in the cabin were 2 flight attendants. The aircraft being used for this flight was just 6 years old and had no reported problems. But given the conditions on this evening, it wasn't the state of the plane that was likely to cause issues. The temperature was 1 degree below freezing, it was snowing, and there was a low cloud ceiling and poor visibility. These conditions had slowed aircraft movements down significantly on this evening, with planes forming long queues to take off. In charge of making sure that Flight 405 got safely out of this mess was 44-year-old Captain Wallace Major. Major was an experienced pilot. He had close to 10,000 hours of flying time, over 2,000 of which were on the Fokker F-28. Over the years, he had also flown the Boeing 737, the DC-9, DC-6, as well as a few other aircraft. He had also been trained to operate in the wintry conditions that blanketed the East Coast on this evening, and he had plenty of experience flying in this kind of weather. Sitting to his right was 30-year-old First Officer John Rachuba. Rachuba was less experienced than Major, however, he still had plenty of flying time, with over 4,500 hours under his belt. That said, most of these hours were on the Boeing 727. He had only just moved to the Fokker the previous month, and so had only 29 hours on it so far. For the crew of Flight 405, it had been a long day. They had started it over 8 hours previously in Tri-Cities, Tennessee, before flying to Charlotte, North Carolina, and then on to Jacksonville, Florida. Owing to the weather over the east coast of the US, they were now running an hour behind schedule. And given the amount of traffic trying to get in and out of LaGuardia, it didn't appear as though this delay was going to get any better. After the aircraft had been parked at the gate for about 30 minutes, the new load of passengers had boarded, and Flight 405 was nearly ready to depart. Because the aircraft hadn't given them any problems that day, neither of the pilots had carried out a walk-around at LaGuardia. This wasn't against company procedures though. At USAir, there was no requirement for the pilots to do this. However, the crew were aware that the main threat to their flight on this evening was ice. Just a small amount of ice on the wings or tail can seriously disrupt the plane's ability to generate lift, making it impossible to fly. So, at 8:15, once everyone and everything was on board, the captain asked for the aircraft to be de-iced. The de-icing crews got to work quickly, spraying the plane with a hot mixture of water and glycol, heated to as much as 82 degrees Celsius. Broadly speaking, there are 2 varieties of de-icing fluid used in commercial aviation. One type removes the existing snow and ice from the aircraft, while the other, known as anti-icing fluid, also prevents new ice from forming. While the latter type had been used to great effect in Europe for several years at this point, the former was much more prevalent in the US. And at LaGuardia, only de-icing fluids were available, the kind that removes existing buildup without preventing more ice from forming. So, that's what Flight 405 got. Once the fluid had been applied, all was set for the pilots to push back from the gate. By now, the passengers and crew alike were eager to get going. They were over an hour late. But just as the pilots were about to call for pushback, some bad news came. One of the 2 de-icing trucks which had sprayed their plane had now broken down behind the aircraft. Flight 405 was now stuck, ironically blocked by the very thing that had enabled them to depart to begin with. And as they waited for the truck to be moved, the snow kept falling. Minute by minute, a new layer began to build up on the aircraft's wings. USAir had provided pilots with a handbook for cold weather operations. It stated that if the elapsed time since de-icing exceeded 20 minutes, careful examination of the wings and tail is required to ensure that there hasn't been a build-up of snow or ice. And sure enough, by the time that the ground crew had managed to move the truck out of the way, those 20 minutes had passed. With the path behind it now clear, Flight 405 was finally pushed back from its stand at LaGuardia. But the story of Flight 405 is not one about recklessness. The pilots knew that the delay they had just experienced had given snow the chance to build up on their aircraft again. What's more, given the queues out to the runway, they could be sure that far more than 20 minutes would pass by the time they were first in line for takeoff. So, the captain ordered a second application of de-icing fluid. That's where this week's sponsor, Odoo, comes in. Odoo is an all-in-one management platform that gives entrepreneurs more than 45 applications which make it simple to manage their business. Everything from invoicing, accounting, project management, and website creation is included, among other apps. In a cockpit, there's more paperwork than people tend to think. Tech logs, fuel sheets, load sheets, and much of this has to be signed. In a modern business though, this is taken to the next level, and it can get messy. What I like about Odoo's Sign app is that it makes this process simple. When you're drawing up documents, you can easily drag and drop editable fields wherever you need them, and make them mandatory or optional. You can determine the signing order so that recipients are only notified when it's their turn to sign. This makes the whole process more streamlined for you and for those who are signing. You can also set up automatic reminders. And what's more, it's not like you just send these documents off for signing and hope for the best. Because they're kept inside Odoo's ecosystem, you can track the status of these documents, seeing who has signed and who hasn't. It's flexible too, because signers can choose to use an automatic signature, or draw it with their mouse or finger, or just load a scan or copy of their signature. They can sign from any device, be it phone, tablet, or laptop. In true Odoo fashion, Sign is integrated with the other apps on the platform, which streamlines your entire operation. You can use the Sign app for free with unlimited hosting and support with Odoo's lifetime one app free plan. Their suite of applications means that as your business grows, you can add on more applications as you need them for an affordable subscription. Thanks again to Odoo for sponsoring this video. Now, back to the video. Once again, the plane was blasted with a hot mixture of water and glycol. Now dripping with a fresh warm coat of de-icing fluid, Flight 405 is finally ready to go. At long last, now well over an hour behind schedule, the pilots started the engines and began taxiing out to runway 13. The captain was flying the aircraft for this leg of the journey, while the first officer talked to air traffic control. Normally, this taxi out to runway 13 would have taken less than 10 minutes. But with all of the traffic building up on this snowy night, the wait was set to be quite a bit longer. And the clock was ticking. As they crawled along the taxiway, the pilots turned on the wing inspection lights. By pressing their heads against the windows and looking back through the darkness, they could see the outer 2/3 of the wing's leading edge. Along the wing was a black strip, which would stand in contrast to any snow that had accumulated. So far, the pilots could see this strip completely, indicating that no snow was present. But there was a long way to go before Flight 405 would reach the runway. So, as a precaution, the captain decided to hold off on deploying the flaps for departure until they got closer. Of course, the flaps would be absolutely necessary for takeoff, providing the plane with greater lift at slow speeds. But with snow falling, it would be better for these all-important devices not to be contaminated before takeoff. Just to make sure he wouldn't end up forgetting to extend the flaps later, the captain put an empty coffee cup on top of the flap lever. It was a rudimentary solution, but in his experience, it had worked. 10 years previously, in Washington, D.C., a Boeing 737 had crashed immediately after takeoff in conditions similar to this. Contributing to that crash was the blockage of some of the plane's engine sensors by ice. To reduce the likelihood of that, the first officer turned on the engine anti-ice switches. This sent hot air from the engine's compressor stages to the engine nacelle, preventing a buildup of ice on the fan blades and the engine sensors. The pilots had a number of considerations like this to make, which were specific to the cold weather as they taxied out to the runway. Another was the speed at which it would be more dangerous to stop on the runway than to continue the takeoff. This is known as the V1 speed, or decision speed, and it's calculated by pilots before every takeoff. On this night, as they taxied out, the captain chose a different speed than the one his calculations suggested. This would have unforeseen consequences when the plane started its takeoff roll. Meter by meter, the pilots crawled forwards on the taxiway, as controllers cleared the aircraft ahead for takeoff. It had now been 5 minutes since Flight 405 had started its taxi. With just 7 planes ahead in the queue, it was looking like they would get airborne soon. Runway 22 was being used for arriving flights, leaving runway 13 completely dedicated to departures. The captain made a PA, informing the passengers of the good news. In a few short minutes, they would be on their way. But then, something happened at the airport that would throw everyone's plans into disarray. An aircraft touched down on runway 22 and was barely able to stop in time, skidding down almost the entire length of the runway on a layer of snow and ice. When they finally managed to vacate the runway, the pilots of that flight reported to air traffic control that the braking action on runway 22 was nil. Controllers immediately shut down the runway and rerouted arriving traffic to runway 13, the runway that was currently being used for departing traffic only, including Flight 405. Now, LaGuardia was using just one runway for all of its departing and arriving aircraft. Facing increasing delays, the pilots of Flight 405 had to make a choice. At this rate, it wasn't looking like they would be taking off anytime soon. Should they stay in line and hope for the best? Or should they return to the gate, wait for the airport to get quieter, and then de-ice again and head back out? It wasn't an easy decision. If they chose to return to the gate, it was quite possible that they would run out of duty time. For safety, pilots and cabin crew can only legally work a certain number of hours per day. If it looked like they were going to exceed those hours by the time they landed in Cleveland, they wouldn't be able to take off from LaGuardia. The flight would be cancelled, and they would be stranded in New York with the passengers until the next day. However, if they continued taxiing out to the runway and took off with ice on their wings, the consequences could be catastrophic. The first officer turned on the ice inspection light again and looked out. The wing was over 30 feet behind him, and through the blackness, it was hard to see clearly. What's more, from where he was seated, he couldn't see the inboard part of the wing. Nonetheless, as far as he could tell, it appeared to be free of snow. The captain looked out his side and saw the same thing. Outside, the snowfall was light. So, the pilots continued their taxi, discussing their flight schedules for the next day and their duty time limits and rest periods, while intermittently using the windscreen wipers to clear them of snow. What they didn't know was that as the snow fell, a thin layer of ice was forming on top of their wings. For every minute they spent taxiing out, this layer got thicker. At 25 minutes past 9, Flight 405 switched over to the LaGuardia tower frequency and received further taxi instructions to bring it closer to the runway. The closer they got to the runway, the harder it became, psychologically, to turn around. And, armed with the strong belief that there was no ice on the wings, and that looking out the cockpit windows was an adequate means of checking the wings, there was little at this point that could dissuade the crew from continuing their taxi. For the passengers who could actually see the wings, though, it was another story. A thin layer of snow had built up on the upper surface of the wings. This wasn't easy to see in the darkness, but it was there nonetheless. Some of the passengers began to get nervous. Finally, at 33 minutes past 9, over half an hour since it had received its second round of de-icing fluid, Flight 405 was first in line for takeoff. The captain extended the flaps to 18 degrees, a setting which was specified in his manuals for takeoff in these conditions. He and the first officer went through their final checklists, and the first officer made a PA telling the cabin crew to take their seats for departure. The tower controller then cleared Flight 405 to line up and wait on runway 13. The captain released the parking brake and nudged the throttles forwards. The first officer reached up and turned on the windscreen wipers. As they lined up, they passed right in front of a Trump shuttle Boeing 727, which was waiting in line as well. The pilots of that plane were sitting quite high up compared to the Fokker, and as far as they could tell, its wings and fuselage were clear of snow. The captain steered the plane onto the runway, taking care not to skid on its slippery surface. USAir's manuals had stated that if 20 minutes had passed since de-icing, the captain would need to do a careful examination of the wings to ensure that it was safe to take off. It was left up to the captain to decide how to interpret the word careful. Did it mean going back to the passenger cabin to look through the windows? Did it mean having somebody physically inspect the wings from the outside, touching them to see if ice had built up? Or was a look out the cockpit windows enough? If either of the pilots had gone back and looked at the wings through a passenger window, they would have seen that the layer had built up, and would likely not have made the decision to line up on the runway for takeoff. But that's not what happened on this night. And in fact, it rarely did happen. There was widespread belief among pilots that looking out the cockpit windows was enough to tell them whether the wings were contaminated with ice. And so, both pilots were confident as they lined up that what they were about to do was safe. What's more, the crew had not been provided with what are known as holdover tables, which detail the amount of time that de-icing fluid would remain effective for after it was applied, depending on the concentration of the fluid and on current conditions. The reality, which the pilots of Flight 405 could not have known, was that in these conditions, with Type 1 de-icing fluid, their wings would only be protected from ice for 11 minutes after de-icing. It had now been 33 minutes since they had been de-iced, literally 3 times longer than this. So, at 34 minutes past 9, when their takeoff clearance came through the radio, the pilots set takeoff power and Flight 405 began rolling down the runway. One last reassurance had come from the fact that every other aircraft they had been in the queue with had been getting airborne just fine. But there was a difference between those aircraft and Flight 405. Most of those planes had one thing that the Fokker F-28 lacked: slats. Slats are movable panels at the front of the wing that basically make the wing bigger, allowing it to generate more lift and prevent the aircraft from stalling at higher angles, like those experienced during takeoff. The Fokker had flaps at the back of the wing, but while these generated lift, helping the plane to fly, they didn't provide a key advantage that slats do. In a matter of seconds, the pilots would find out firsthand what this was. As the plane accelerated down the runway, the pilots checked that the power was correctly set, which it was. Before long, they had passed 80 knots, and they checked that both of their airspeed indicators gave the same reading, which they did. Their engines were working, their airspeed indicators were working, and the plane was accelerating at a normal rate. Everything was looking good. The next point that the pilots would reach was V1, the point of no return. If there is a major problem during the takeoff run, such as an engine failure, and it happens before V1, pilots can abort the takeoff. If the failure happens after V1 though, the pilots must continue the takeoff and get the plane into the air. Obviously, wet runways, or runways covered in ice or snow, will take longer to stop on than dry runways, and so a lower decision speed is used, giving the aircraft more room to stop. On this night, on LaGuardia's snow-covered runway, the pilots had correctly calculated their decision speed to be 124 knots. Before this speed, they would stop for a big problem. After it, they were committed to the takeoff. This speed took into account the condition of the runway, but even so, the captain considered 124 knots to be too fast. So he had told the first officer during the taxi that he would be reducing the V1 speed further to 110 knots. This was not an authorized procedure. However, the captain reasoned that it could only serve to enhance safety. He was being extra conservative in his decision to abort the takeoff at an even lower speed than the calculations showed. But this decision would now have an unforeseen consequence, and it had to do with the next speed the pilots would encounter, rotation speed, or VR. This is the speed at which the aircraft is going fast enough that it's able to fly. When Flight 405 reached this speed, the first officer would call out rotate, and the captain would pull back on the control column and bring the plane into the air. On this night, as is often the case, that speed was the same as V1, 124 knots. Given how close together V1 and VR normally are, pilots are in the habit of saying V1 rotate, almost as a stock phrase. But the reality is, these are very different speeds, with very different purposes. Flight 405 continued accelerating down the runway, its nose wheel hitting the centerline lights, providing a rhythmic thumping like a drum roll for takeoff. The passengers readied themselves. Many had seen the snow on the wings and were anxious about the plane's ability to fly. And then, the moment came. The aircraft reached 110 knots, and the first officer called out V1. Now, there was no turning back. The captain took his right hand off the throttles so as to remove any temptation to pull them back if a problem occurred now. But then, the first officer, rather than waiting until 124 knots to call rotate, reverted to habit and called it immediately after calling V1. The captain held off for a moment, perhaps reluctant to rotate this soon, when he knew that there was supposed to be a 14-knot gap between V1 and rotate. But still, he didn't wait long enough. 5 knots before the proper rotate speed of 124 knots, the captain began pulling back on his control column. On a normal day, this would not have been a problem. But this was not a normal day. As the captain pulled, the plane's nose left the ground. A plane generates lift only when there is a smooth flow of air over the top of the wing. If the angle that the wing makes with the oncoming air is too steep, when the air reaches the leading edge of the wing, it can't make the turn fast enough to stay connected to the wing's upper surface. So, the airflow simply disconnects from the top of the wing, and the wing stops acting like a wing. It stops generating lift. This is an aerodynamic stall. When it happens, the plane just becomes dead weight, and it falls from the sky. And this is where a unique aspect of the Fokker F-28's design would play a crucial role in what was about to happen. While the Fokker F-28 had flaps at the back of the wing, it lacked slats at the front. By extending into the airflow and making the wing bigger, more curved, and by providing an extra gap for air to come through and zip over the top of the wing, slats allow the wing to reach even greater angles before stalling. But without slats, the F-28 didn't have the luxury of being able to reach these greater angles. And with a thin layer of ice, barely more than the thickness of sandpaper, coating the tops of its wings, the angle at which the flow over the top of the wing would separate was even less. In other words, everything was against the pilots of Flight 405 as they brought their plane into the air. The margin for error was basically non-existent. The captain continued pulling back, and moments after the nose wheel lifted into the air, the main wheels joined it. Flight 405 was airborne. But only just. The captain continued pulling back until the nose was pitched 15 degrees above the horizon. This was the normal takeoff attitude, but with ice on the wings and with an airspeed 5 knots slower than normal, it was too much. The plane's angle of attack sensors, which weather vane to measure the angle the plane is making with the oncoming air, detected that the plane was making too steep of an angle with the air, and therefore the wings were very close to stalling. As a result, the pilot's control columns started shaking violently, a warning built in to alert them that they were close to stalling. Then, the stall warning sounded, signaling the same thing. The captain carefully held the nose up to stay airborne, but he didn't try to climb. Doing so would cause the plane to stall instantly. Instead, he kept the aircraft in a shallow nose-up attitude, trying to maintain speed. With the left wing making less lift than the right, the plane rolled to the left and began heading towards the bay. The captain leveled the wings, and the first officer joined him on the controls. Both pilots knew that their aircraft was not going to fly. They carefully tried to steer the plane to the right using the rudder to stay over the ground and avoid going into the water. But despite their best efforts, just seconds after getting airborne, the left wing stalled. A mere 13 seconds after leaving the ground, Flight 405 came crashing down to the left of the runway, hitting a localizer antenna and a water pump house, and then tumbling into the freezing cold waters of Flushing Bay. 27 of the 51 people on board died, many of whom survived the initial impact, but ended up drowning. Among the dead was Captain Major. The crash of Flight 405 prompted massive changes in how airlines deal with the problems of cold weather. Changes which are still in place today. Perhaps the biggest of these is in the cultural attitude within the airline industry towards airframe icing. Nowadays, airlines promote a clean aircraft concept, where no amount of contamination on the aircraft's critical surfaces is considered safe. There is also much more widespread use of anti-icing fluids rather than simply de-icing fluids, as these last longer and prevent the buildup of ice for a given time. Alongside this, pilots are now provided with holdover tables, which specify very clearly how long their wings are protected by anti-ice fluid after it's been applied. Something that would have been beneficial not just to the pilots of Flight 405, but to every aircraft taking off out of LaGuardia on that day, was a de-icing pad near the runway, instead of just at the gate. Many airports around the world have now installed these systems, allowing aircraft to be de-iced right before takeoff. Even with advances in technology, severe weather still poses a threat to aircraft today. The changes that resulted from the crash of USAir Flight 405 have meant that this threat is now respected and dealt with more effectively than before.